So today we continue from where we stopped in our introduction to classification. And remember, we are now talking about the second aspect of supervised learning, and that is classification. Today we are going to be looking at a typical example of classification. And just to remind you, classification is a situation whereby you have the target variables or the dependent variable to be categorical or discrete. I already explained the difference between these, and I also explained the difference between classification and regression, as you can see on the screen right here. So let's now take a typical example of classification, and that is about the question of cancer diagnosis. This is very important in the medical field because if a patient is diagnosed, he can either be diagnosed to have cancer or not. Maybe he's showing some symptoms, he discovers some symptoms in the body, and then he goes to the doctor to check what really is this growth in my body. Is it cancer or something else? Since to diagnose cancer is difficult, they now have to do maybe some x-ray or some tests and then come out with a decision: there is cancer or there is no cancer. But one thing I want to tell you is that at some point the doctors get it wrong. A few amount of the time the doctors actually get it wrong. Somebody might actually not have cancer, and they decide classify him as having cancer and they give a cancer treatment. But that is not really too bad. But the question is, if somebody actually have cancer and he's classified as not having cancer and he's not given a treatment, that is where the problem actually lies. Anyway, we'll talk about more about this when we're talking about how to minimize false negative, because we've talked about false positive and false negative, but we'll discuss this in another class. So let's go to the screen and see example of classification problem. I'm going to actually wipe my screen a bit so that I'll be able to write. I'm going to wipe here. Let's say wipe. Good. All right. So in case of medical diagnosis, let's say the doctors want to diagnose a cancer patient or a supposed cancer patient. What they do is to do an X-ray. For example, one of the tests they do is an X-ray test. So based on this X-ray, they can now classify the patient as having cancer or not having cancer. Although when they want to do this in the real life situation in the hospital, they do X-ray and other things, not just X-ray. So alright, so the patient's X-ray comes out and we have it as an X-ray image. Now in this class, we can say this X-ray image is an image being a collection of pixels, right? So let's say is a collection vector or a vector of pixels, or a list of several pixels, because an image contains several pixels. So now if the patient has cancer, we'll have two output class. One, C1 denotes the presence of cancer, C2 denotes the absence of cancer. So in this case, even though 1,000 patients, they can only classify these 1,000 patients as either C1 or C2, only two classes. So in that case, we'll have something like this where we have only two classes, C1 and C2. Of course, in classification, we can also have a situation where there is maybe 3 classes or 4 classes. So let's say, so the input will be considered to be X, set of X-ray images or set of pixel intensities. So it means that X maybe is equal to, have 24. Let's assume these numbers represent intensity: 16, 17, 5, 10, 6, 4.2, and so on. So several pixels making up the image, and the output class Y will be C1 or C2. Okay. So let's now go down a bit to see how probability plays out in this place. So the question that will be asked is, what is the probability that an X-ray image has certain set of pixel intensities and the patient have cancer? So what we'll be talking about is, if let's say we have X, let's say Xi has been determined for patient I, we have Xi, and we need to determine if it's C1, C2 or C1. The question is, given these X-ray images we have, what is the probability that the patients have cancer given these X-ray images? Or let's put it this way, what is the probability that the patients have cancer with these X-ray images we have? And that is called joint probability. So there's two approaches to the problem. One is to determine the joint probability distribution, which is Px of Cx. So we are going to determine probability that there is an X-ray image that belongs to cancer where X, in this case, actually we have this case Ck, where K is equal to 1 or 2. So in this case we have C1 or C2. So given X, what is the probability that we have an X-ray image and the person have cancer? That is what we want to determine. And the second aspect is inference. Given this probability, then make a decision on which action to take. This is what forms the basis of decision theory, and I made a video on decision theory. You can see the link there, so I recommend you watch this video and get a clear understanding. So now we've introduced joint probability, and we can't go any much further from here because I would like you to spend some time to review probability theory, about joint probability, conditional probability, and marginal probability. So review these things, and then take some time to do this quiz. We have, what are the three fundamental theories of machine learning? This is just a single question I would like you to answer. So leave your answer in the description box below this video. And in the next class, let's see what we are going to do. We are going to see a kind of classifier that works the way we've described, a classifier that is called Bayes classifier. That is what we are going to be looking at in the next class. Remember, this is procedure-based class. Maybe I did not explain it perfectly, but everything is clarified in my website. The procedure is well explained in my website. Everything I want to say is explained there. So feel free to go visit it, try to understand everything I've mentioned. Remember to subscribe, also share this video, and let me know by leaving a comment on what you would like me to do.